Walk onto almost any large construction site, and you'll likely see a lot of activity masking a profound amount of stillness. Heavy machinery roars into position, but right next to it, skilled tradespeople are forced to stand by, waiting for clearances, materials, or instructions. The delay usually isn't caused by a lack of effort. It stems from a massive amount of hidden, unmeasured waste baked directly into the schedule itself. To diagnose exactly where all that time goes, project managers divide labor into three distinct categories: productive work, contributory work, and non-contributory work. Looking at these pie charts of worker time distribution, you can see the severity of the problem. Productive work, like pouring concrete or laying brick, is only a fraction of the day. The large red and green sections represent non-contributory work, which is pure waste, like waiting and rework, and contributory work, which includes necessary but non-value-adding tasks like moving materials across a site. Traditional management methods historically ignored this massive block of wasted time, treating delays as unavoidable. To fix it, the industry had to look outside of construction entirely. The solution came from manufacturing, specifically the high-efficiency assembly lines at Toyota. By adapting these principles, builders developed a new framework known as lean construction. The core idea is simple: stop treating a job site like a reactive, chaotic battlefield and start running it like a precise, continuous production line. Making that shift doesn't begin with pouring concrete. It starts weeks before anyone breaks ground, inside a planning room. Traditional master schedules often fail because they are drafted in isolation by executives or managers who are completely disconnected from the physical realities of the site. Lean construction replaces those top-down mandates with the last planner system. This approach requires the foremen, site supervisors, and the actual crew leaders, the last planners, to sit down together and collaboratively build the schedule. They rely on a process called pull planning. Instead of plotting tasks forward from day one, the team identifies a final milestone and works backward, determining exactly which tasks must be completed to unlock the next. Once that sequence is set, they use a look-ahead phase. By peering 3 to 6 weeks into the future, the team can spot missing permits or delayed material deliveries and resolve them before they cause actual work stoppages. The resulting schedule is no longer a dictatorial wish list. It becomes a reliable, reality-based network of commitments made by the people actually doing the building. When those commitments hit the active construction site, the collaborative plan translates into synchronized physical movement. You start to see crews flowing through the structure without bottlenecks or sudden stops. This rhythm is achieved through tact planning, a mechanism that converts the last planner commitments into a physical pulse for the site. The entire project is divided into equal spatial sectors. This allows different specialized crews, like electricians or drywallers, to move through the building sequentially, one after another. Project managers balance the crew sizes across these sectors so that the work takes the exact same amount of time in each zone. This creates a continuous train of activities that never stops or overcrowds a single area. This constant, measured movement is exactly how lean principles systematically eliminate all that non-contributory waste of waiting around and stacking trades on top of each other. Tact planning forces what would normally be isolated, clashing contractors to operate as a tightly synchronized assembly line. Even with a perfectly orchestrated plan, a physical job site will eventually encounter unpredictable field variations, from extreme weather to equipment failure. To keep the project on track, lean managers track a metric called Percent Plan Complete, or PPC. It serves as an objective standard for the reliability of the system, rather than a tool for punishing workers. By calculating the ratio of promises kept versus promises made, teams get an accurate, real-time pulse of the project's health. When a task fails, the team logs it as a cause of non-compliance, isolating the exact point where the breakdown occurred. They then apply the 5 whys methodology, asking why repeatedly to trace the failure down to its structural root cause. This ensures the specific error is permanently engineered out of the workflow, rather than just patched over for the day. Lean construction strips away the guesswork and the waste. By empowering workers to plan their tasks and using precise data to solve problems, it allows teams to build physical progress intelligently and flawlessly.